Good afternoon and welcome to this webinar, Small Pond, Big Performance, Pond Loop, Geothermal Loop Design. This event, brought to you by the ACHR News, is sponsored by Climate Master. I'm your moderator, Kyle Gargaro, Editor-in-Chief of the News. Thanks for joining us. Today's presenter is Sean Hogan, Technical Trainer, Climate Master. Sean began his career in green technologies in 1981, installing solar and geothermal systems in the Pacific Northwest. He quickly recognized the unique opportunities and benefits pond loops presented and began to focus his marketing efforts to waterfront property owners in the greater Seattle area. Sean started his own HVAC company in 1984 and has installed well over 600 pond loops and countless ground and open loop systems that include large mansions, houseboats, private yachts, the U.S. Navy, and a cruise ship. Sean is a technical trainer for Climate Master and IGS HPA, traveling across North America teaching his do-it-right or stay-home approach. He continues to size and design systems, consult on projects, and test new loop designs, equipment, and accessories. Sean also lives what he teaches, having enjoyed the comfort and savings of geothermal, providing his rural Seattle home with heating, cooling, and hot water with solar assist for nearly 20 years. And now, I'm very excited to turn this over to today's presenter, Sean Hogan.
Well, good day, everybody. Not sure which time zones y'all are in, but thank you for joining us. We're going to cover a lot of stuff here. We're going to go through a great deal of information, and if we don't quite cover the areas that are uniquely interesting to you, please let us know. We'll do our very best to get to it either during the program today or perhaps afterwards. So again, thanks for joining us. Let's get started here. Power of water. Basically, 3/4 of the earth is covered by water, so it's a significant source that's available to us. I've related it to it's like living next to a volcano and you need heat. It's a significant energy source that is really difficult and challenging to outrun. If you do things correctly, you're going to hear me kind of repeat that mantra several times during this presentation. So we see, some see a pond, we see basically a renewable resource, a power plant, when you apply it correctly and get the correct amount of depth, which again we're going to cover. Here's a quick, I'm not going to read this all to you, but for those of you that might like data, for those engineers in the crowd, basically here's the formula so you can determine what is the availability of BTU out of a 1 acre pond 10 feet deep. Basically almost 27 million BTUs. So it's significant. So there's a lot of BTUs available both for heating and cooling in a body of water that has enough surface and depth area. Rule of thumbs, and I will tell you I'm not a big fan of rules of thumb in geothermal, but it is the least expensive of your geothermal closed loop because it typically takes much less heat exchange surface area when you have it submerged in water itself. You want to have a minimum half-acre pond, and you want to make sure you have that depth. 1,500 to 3,000 square feet per ton is a good number to use for sizing. Again, it's almost double to 3,000, and that really depends upon your load conditions where you're at. You really want to have that pond within about 300 feet of that structure because by the time you've actually achieved entrance into that pond, you could nearly have your ground loop in. You also start running some pumping and purging issues when you have exceedingly long supply and return lines. In the north, not that you have any control over it, a good ice cover early in the season is great. It actually kind of puts a cork in that bottle and prevents a lot of aeration, a lot of evaporative temperature loss. Stagnant water works well for heating. So you get a customer that calls you. That is not your cue, guys, to jump behind the windshield of your truck and run out there. You want to start by asking a lot of questions. For example, Mr. Homeowner, is it a year-round pond? Because I'll tell you, I've been awfully surprised how many people, when you ask them that question, will say, well, I don't have much of one during the summer. No, that's not a pond, that's a mud puddle. Mr. Homeowner, what's the depth at the lowest point of the year? Again, that area that you can place the heat exchanger, you want to know what that depth is from the surface at the lowest point. Mr. Homeowner, is that bottom firm or is it solid and or muddy and silty? If you were to stand out there, Mr. Homeowner, at the depth we're discussing on the bottom, would you sink into the mud? If so, how far? That is, again, something that you need to consider, because the heat exchanger actually needs to be submerged in water. If it gets entombed in mud, well, you've got a problem because you don't have enough heat exchange available to the water. The water doesn't move. Is there a year-round dock repair? I've always found that it's best if I can secure my heat exchanger within the confines of that dock repair, just a little bit of added protection, but as long as I can get my depth. What is the shoreline entry to the pond like? In other words, where you need to bring your supply and return pipes in. Is it a rockery? Is it concrete? Is it wood? Is it lawn? Is it landscape? Is it natural vegetation? Those kinds of things need to be a consideration. Does the pond have flow from a spring or a creek? That can be important, number one, because that might have some impacts on the elevation. In other words, the depth of that pond. It might bring in some unwanted items like a lot of mud and silt. I had a project actually where it was fed from a pond way up on the hill above this homeowner's pond. Well, the beaver dam broke and brought in a whole lot of mud and debris and entombed his heat exchanger some 8 or 9 years after it was installed in mud, and he had very, very poor performance. What are your expectations of the system? I'm just sharing that because that is something that I have found you really need to find out from the homeowner what their expectations are before you install the project. Sometimes they're low, if that's good for you. Sometimes they're not realistic, and it's better to actually help readjust their expectation for the system before you get it installed rather than after. Is depth important? Yes. Minimum of 8 feet over the top of the heat exchanger, depending upon the type of heat exchanger you install. And if you're in the northern parts of the country, we want a minimum of 6 feet below the ice sheet. The other part that I really harp on in talking about pond loops is the number one reason for depth really is swimmer safety. And that's something I want you to all consider, is that you may have a body of water where there's a lot of recreation activity, and you want to make sure that the heat exchanger is at a depth where swimmers really can't get to it. You don't want to have a tragic result of someone getting to it and maybe perhaps getting tangled up. The other reason is minimal thermal influence from the ambient air conditions, air temperatures that are going on out there. Again, that's one of the significant advantages of pond loops. Obviously, we want depth so we don't become a navigation hazard. So for you that are contractors and dealers, well, contractor checklist. Swimmer safety first and always. Again, you just heard me mention that. That is something that I really want to stress, and something you definitely want to make sure you cover first and foremost. Make sure you always do your heating and cooling load calculations. Guys, rule of thumb does not apply to geothermal. Use only non-toxic antifreeze. I'm not a big fan of propylene glycol, the food-grade antifreeze, because it gets viscous and difficult to pump when it gets chilled. If you're in a more northern environment, I prefer the alcohol, the ethanol alcohol. It mixes well and it's easier to pump. How will your supply and return pipe enter and exit the pond? Again, this is something you need to discuss with that project superintendent, homeowner, whoever it happens to be. And if you have a muddy or silty bottom, well, you need to design for that. So you need to determine, is that an environment you're going to be dealing with? We can work around that. We'll cover that. Can you use the dock to shield the heat exchanger? Again, sometimes there's some advantages to doing that if it's available. Do regulations allow for the pond loops? Some areas that's somewhat challenging. I've had some challenges up here in the greater Northwest area. But it's typically just a matter of informing and getting the regulators the correct information, because if you think about it, their most natural and safest answer they can give you when they don't understand something is to say, no, you can't do it. So I oftentimes will get a no initially, and then once you inform them, it usually evolves into a yes. And then, again, a discussion you need to have with whomever you're dealing with on that project, who's going to restore the landscaping after the installation. So just, again, an area you want to have covered. Let's talk about the various types of heat exchangers. HDPE pipe, high-density polyethylene pipe. Again, typically it's 3/4 inch pipe, 300 to 500 foot length per ton, again, depending upon the environment and your particular load conditions. You must have, and this is a crucial component, must have adequate spacing within those tubes for proper heat transfer. Requires a minimum of 75 pounds. I want to emphasize that. Minimum 75 pounds per 300 feet of 3/4 inch pipe to sink it. Folks, when you actually flush all the air out of a coil of pipe and flood it with water, it still will not sink. It's still buoyant. You must add the appropriate amount of weight to take it to the bottom. These do not perform well if they get into the mud and silt. Again, you have significantly less heat exchange area in a pond loop, but if it becomes a saturated ground loop because it is sunk into the abyss, you're going to have a problem with it. Coincidentally, the HDPE pipe does not seem to be affected by barnacles in a saltwater application. I've done a number of these, and I've had homeowners from the late 80s that reported back to me that barnacles actually didn't like the HDPE pipe, and I was quite surprised. I didn't know there was anything barnacles didn't like. By the way, the barnacles I have found from the Department of Navy do not inhibit any thermal transfer of temperature. They had done studies on it. Here's a couple of examples of some pond loop heat exchangers. The one on the left is your typical 300-foot coils. This is an old drawing. There's some things about it I don't prefer. I want to address that. It shows the concrete blocks or weight attached to the actual coil. You're going to see some pictures later. I'm not a fan of that. I want to make sure that you create some separation so that you don't have the abrasion and potentially with your expansion contraction of the pipe because of the thermal differences from season to season and or some wave action, some other movement down the bottom. You don't want to have that sawing through the pipe over time. I've seen issues there. You're seeing the slinky mat on the right-hand side, and again, you're seeing bricks and blocks kind of stacked on top of it. I prefer a PVC grid or something of that nature that separates that. You attach your blocks underneath that and attach that to the PVC framework. Again, the bricks can actually act as a bit of a leg to keep it up off the bottom a little bit. It also keeps it from attaching itself, or excuse me, upbraiding through the pipe and causing some breaching of the pipe. The other thing to consider is that you need to make sure that the spacing of your concrete or whatever your weight happens to be, you want to make sure that these things are built fairly uniformly, square, even, and you evenly distribute the blocks, because if you don't do that, if you don't secure them really, really well to your framework, you're going to have problems when they go to sink. They won't go straight flat down like you would imagine. They can actually turtle over and do a lot of other things and create a little bit of a problem for you. So want to save you from all those errors that I made early in my career. Here's a close-up picture of some pond space 3/4 inch coils. You can see that we have some nylon separators here. I'll show you another view. Here's a vertical view so that we have good separation so the water can flow amongst the individual tubes, because here's the thing you want to make sure you do. Have all that surface area available so water can circulate around it. Remember, when you create a temperature change around this heat exchanger, cold drops, heat rises. So as soon as you start to introduce temperature to that heat exchanger, you're going to start some water movement if there wasn't any movement prior to. So it's important to make sure you have proper spacing and you're using all the surface area of all those tubes. We don't put in a lot of spare capacity here, folks. So taking a pond coil, or excuse me, just taking a 300-foot coil of pipe that you get from your vendor that's all banded together and welding it up with some headers and kicking it into the pond, you're going to have problems, I promise you. So make sure you're doing it properly. We do have these for sale through our distribution network. Here's some examples I want to kind of cover real quickly. You can see here the Kevin Heide Special, named after a gentleman down in the greater Oregon area. Space coils available again from Climate Master. This is a little 2-ton. These are each 300-foot coils. We have manifolded these. You can see the plastic PVC 2-inch pipe frame that we use to create our spacing on the coils. I like to see 3 to 4 feet minimum between the coils. You want to use nylon zip ties. Again, I want to emphasize nylon zip ties because that is something that down below in the water, there's no ultraviolet, so the nylon zip ties typically are going to last, well, a couple of lifetimes. They don't tend to degrade. But you want to lock them down well so that when you're moving the pond loop into place and you're going to sink it, they don't move. You can see the concrete cinder blocks, and they are secured very tightly, again, to the framework, so they're acting as a leg to keep it up off the bottom. But also you can see they're evenly distributed so that this will go down fairly straight. The one in the middle is what we call a Hyperloop. This is a emerging technology. I've got a couple of these out on test. I'm just letting you know that they exist. We'll cover more of these later. There's some things you need to know about those. Slinky mat. Slinky mat is one that I preferred. I did a lot of these. One of the things that I would do is take some long 2-inch pipe and typically drill a bunch of holes to full length, put a cap on one end, put it on the top of each one of the slinky mats, which then I put another slinky mat on top of that, cinch the two together with your nylon zip ties, and you can start to stack them up vertically with those 2-inch separation pipes and whatnot. I would then put some steel pipe, typically 1 inch, 1.25 inch, galvanized if I could find enough, and I would put those inside those 2-inch PVC tubes and put another cap on the outside. And what did I just do? I added my weight. It's not rubbing against my coils, and it's evenly distributed length and width, making sure, again, I use a slinky template to create my slinky map so that they were uniformly the same dimension, typically 16 feet by 4 feet approximately. So I did a great deal of those. But you want to make sure that you're providing the method to keep them up out of the mud and silt. Perhaps you're going to build a PVC framework with table legs. We don't really care if the table legs go down in the mud. We just want to make sure your heat exchanger stays up and out of the abyss so that you can actually get good water movement around these coils. Here's an example of that pond loop. You can see it's floating nice and evenly with those blocks. And the reason it's still floating is we still have air in those coils. And trust me, when you attach an appropriate flush cart to the ends of this connection at the heat pump, and you go to introduce the fluid, this bad boy goes right down. And again, if you've spread that weight out evenly, it's going to go down very nicely and very evenly. If you didn't secure concrete blocks and you come down the embankment to send this thing out into the water, the concrete blocks may shift. And what will happen is when this thing goes to sink, maybe the concrete blocks all head down to the tip of that, and the end of it doesn't quite go to the bottom, so it's kind of standing on end. So again, you might have part of your coil down at the depth you want. The remains, well, maybe not so much. So again, something to consider. Also bear in mind, you're going to need to add some weight to your supply and return pipes going to and from the beach. You want to make sure you're doing that so again, your weight doesn't cause any abrasion and rupture or breach that pipe. I oftentimes would use a flexible PVC pipe as a sleeve over some of those areas where I would apply my weighting or my anchoring to the lake bed. Again, if you're using a dock, you can use some of those pilings to secure your piping. Here's an example of a large commercial project. You can see reverse return manifolding. This is crucial when you're using spaced coils to ensure good air removal, always a part of any loop design, and for balanced fluid flow so that each circuit is getting the appropriate flow evenly dispersed throughout this loop array. You can see here this particular project has some concrete blocks, again, attached to the coils themselves. I recommend you don't do that. I would have personally put this PVC rack on the bottom of the coils and weighted them there. Here's an option to consider. How are you going to get to and from that lake? Well, directional bore machines are they're getting to be fairly commonplace, and this can actually bring a nice little element into being able to get from the project, the near heat pump location. It can go under the terrain and perhaps just avoid the whole bulkhead and surface up into the pond. Here's a picture of just exactly that. They know exactly where they're at with their transponders, and that piping can come out right through that directional bore hole out into the pond. You can see that pond heat exchanger out in the pond. They're starting to pull the lines back with that directional bore bit back through that hole back to where the machine is sitting, and that's where they'll make their connections to the pipes going into the home. So this can bring a nice element to not having to restore landscape or deal with your entry and exit depending on the bulkhead that you have to deal with there. Some regulators, depending upon the fisheries and others that have concerns, they don't want you disturbing the natural vegetation along certain lake shorelines. This can perhaps give that answer to everybody with those concerns. Guys tossing bundles of pipe in the water, well, typically not going to be very successful. This was a project down in Texas. The homeowner had a lot of grief with it. He pumped down this, I believe it was a man-made pond. He pumped it down, and it became fairly apparent what the multitude of issues were. And again, this is what kind of hurts our industry, is when guys go out and just kind of cowboy stuff up. So again, making sure you're doing it right and apply the project design correctly. One of the issues this one had was that it was so far away. You can see the blue arrow in the picture. These were going to a couple of barns. You can see a multitude of heat exchangers, because I believe they also went to the house. But they were significantly far away. I mean, one of the barns had 1,560 feet of 1.25" pipe. That's not the pond loop pipe, because that stuff was 1-inch pipe. But that is a long distance in supply and return pipe. And to be honest with you, you probably should have just buried a ground loop. This was not a good application because of the distance between the particular barns, to the pond loop. So again, I want to emphasize that is a consideration not to be ignored. Here's another example of a slinky loop. Again, some guys do variations of their own. This one is lacking, obviously, any kind of a framework. I know a lot of people put PVC frame, kind of like what you saw with the slinky coils. That's just fine. Again, keeping it up out of the mud. Evenly distributing that weight so it stays to the bottom, and your manifolding. Making sure that your ability to disperse your flow evenly and properly, as well as, again, I want to emphasize good design conditions so that you're able to purge the air out of the loop. That's just a critical component of every geothermal closed loop design. The emphasis here is making sure that you have the separation of your heat exchange surface, which is all your tubing, making sure that that water can flow and transfer and conduct that temperature. So we're going to change up to plate-style pond heat exchangers. Plate as in, you're going to see some examples in just a moment here, stainless steel or titanium. Stainless steel is typically what is used. However, the manufacturers I'm aware of also manufacture titanium plate construction heat exchangers. When would you use titanium? Well, titanium would be in a very brackish or aggressive water, and or some saltwater applications. I've actually done both. Some of the advantages, well, they typically have low fluid volume. They're typically 3/8 inch thick between the walls, and they don't have much pressure drop for fluid flow. Some things you need to be aware of, folks. Must be installed in a vertical position and up and out of the mud and silt. For those of you that live in a heating dominant climate, I want to make sure you are very well informed. You must size that particular plate heat exchanger for your temperature of your pond water and your dominant load profile. Please make sure you contact the manufacturer of your choice for these plate heat exchangers and work with them to make sure you have the appropriate size for your area. That has been an issue. Some manufacturers, they will rate their plates at the BTU heat of rejection, and when you bring that size plate up into the northern heating dominant climates and you start to get into that cold water, you don't have enough heat exchanger in there to support that particular size in that environment. So make sure if you're going to apply these plate heat exchangers, you're working with that manufacturer to ensure that it is sized correctly for your location. So here's an example. Again, the plate heat exchanger must stand vertical and up off the bottom. Again, making sure you have that depth, minimum depth over the top of the heat exchanger. You don't want to be affected by the elements going on outside. Here is the Slim Jim. It's made down in Louisiana, AWeb Supply, and I emphasize this red highlighted box here where they even mention here that you need to work with them. You need to contact them if you're going to a heating dominant application. You're in a chilled water environment. So make sure that you do that. Just don't go to their website and order that size for a 5-ton heat pump, you're in the northern climate because you're going to be undersized if you take one just off their website and apply it to your heating dominant load needs. So please make sure you do that. They're great heat exchangers, have no qualms with them. I just want to make sure that everybody has the right size for the application. Here's Alan Watts, one of the owners of AWeb Design and one of his lake plates. Again, this one is stainless steel. You can see his float on the top to keep it vertical, and then the PVC stand to keep it up off the bottom, the supply and return pipes connected, ready to go. Here's an example of multiple lake plates manifolded. I've done a few of these myself. They put it on a little skid to drag it out into that lake bed, again making sure that you're not going to be placing into a muddy environment where it may sink and start to get into the exchange area of those plates. Because remember, you need both sides of that heat exchange lake plate so that you're conducting the BTUs you need. Here's another brand, EnviroPlate by Major Geothermal, one of our distributors up in the Colorado area. They won't actually, as I understand it, they won't provide you with a lake plate. It's a very, very similar lake plate as a Slim Jim until you've actually gone through and filled out this sheet, because they want to make sure for your application, give your load of your particular project, both heating and cooling, and the particulars of your pond profile, they will make sure that they have designed the plate heat exchanger for what you need for that application. So I like that approach, and making sure that what they provide you is going to meet the performance criteria and satisfy everybody's expectations. That's always critical in every project. Here's an example cutaway. Again, as I mentioned, there's not a lot of fluid volume in here. There's not a lot of pressure drop. So when you're using either of these kinds of lake plate heat exchangers, you typically will want to pay attention to your pump sizing, because if you just kind of do it by gosh and by golly rule of thumb, you are likely going to be over pumped. So doing a good pressure drop analysis with your heat exchanger and your piping system between that lake plate as well as that lake plate, make sure you're putting in the appropriate pump, not too big, not too little. You don't want to throw away your energy savings with your geothermal heat pump in pumping watts. So make sure that you're applying good design characteristics and techniques to each and every project. It's really crucial that you do that. Here's an example of a high altitude up in Aspen, Colorado, where they have a man-made pond, and they place the lake plate heat exchangers up in there. These can go in a lot of different environments. Again, you can see this is already pre-manufactured. They have the manifolds in place. You can see the reverse return, as well as proper spacing, and they're obviously on that grid. Emerging technologies. Well, there's all kinds of new heat exchange materials, designs, and concepts. They come out frequently. We go to the IGSPA annual conference, and there's typically a couple of different kinds of new geothermal heat transfer technologies out there. And in no way am I putting any of them down. I think innovation is a wonderful thing. The thing that I want to emphasize here for those of you that don't have a lot of experience is you want to approach with caution. You want to exercise caution. Most people have good intentions with their product in geothermal, but you want to just be careful. Don't be that person that runs out there and tries to be first on the block with this new technology, because if it doesn't perform, you're pretty much the person on the hook, and you don't want to damage your reputation if it doesn't perform as well the salesperson told you. So again, I kind of made this tongue-in-cheek comment, pioneers are often scalped. We have to have pioneers. However, you may want to consider having a discussion with the homeowner if you're going to try some of these, saying, look, I haven't tried these before. It looks like it'll work fine, but I just want to make sure that we're on the same page. If it doesn't, I'll stand behind it, or whatever your conversation needs to be. So I mentioned that Hyperloop earlier. Again, this is a 3-foot by almost 19-foot, 18-foot 8-inch. It has a bunch of very small tubes, perhaps about the diameter of a pencil. Manifold on each end. Some things to be aware of. You got to be careful about the manifolding of these so that you can get good air removal. In the pond, the manufacturer is stating that it is 2 tons of capacity. I want to tell you that you want to make sure that you don't undersize these, as with any particular project. I will tell you that I have one of these out on test. I've got so many customers with pond loops. If I see something I want to try, I'll call them up. Hey, do you mind if I play around with your system? And most of my customers don't care because they know I'm going to take care of them. So I actually have this out on a pond loop application. I have a 5-ton heat pump on 3 of these, so I'm a little oversized based upon the manufacturer. I have a 5-ton heat pump with a lake plate heat exchanger on one side, my customer with the Hyperloop in the center, and another one with the HDPE coil. So I have 3 5-ton houses and I'm testing 3 different kinds of heat exchangers, and I'll do that for some time. So when I'm asked, I can tell what my experience is. So far, my customer is reporting back that the performance has been just fine. However, we really haven't had the heating dominant season up here in the Seattle area yet to test this particular application. Here's an example that they have on their website. They show it on a plastic framework. Thing again to be aware of, if it's a body of water where there will be fishermen, the wall thickness of these small tubes are prone to be punctured by fish hooks because they're fairly thin wall. Not that that's a bad thing, I just want to make you aware of it. Where I installed this up here in Seattle, I actually put some expanded aluminum metal around the heat exchanger to prevent any fish hooks, because people bass fish almost year round and cast underneath the dock because that's where they believe the bass linger. So I just made sure that I designed it around that particular potential issue. But so far, like I mentioned, it seems to be performing just fine. Here's another one that maybe you've seen, maybe you have not. This is made out of Canada, and it's interesting. I have not had one to test. Sure would like to get one from them and put it out on test. Some things about it. Well, it's got a lead weight that keeps it from moving around, but it actually floats. It actually floats itself up off the bottom, but it's secured by that anchor weight. Purges fairly easily from what I have seen recently at a project. It's one size fits all currently, as I understand it, and it can be a little bit on the pricey side. So hopefully this is a system that will prove thermal performance out on multiple projects, both heating dominant and cooling dominant, and there will get some pricing that will be more advantageous for, well, the sizes of systems that are more conducive to residential applications. Right now, as I understand it, this one size fits all is about 7.5 tons, and it's quite expensive in my opinion when you look at the tonnage for a pond loop heat exchanger. But again, I have not yet tested one. I just want to make sure that y'all are aware that it is out there. Here again, it's fairly easy to install. It's not very large physically. It doesn't weigh much until you put that anchor on the bottom of it. Thought I'd throw in a few examples of some of my projects. For those of you that might have heard, as I say tongue-in-cheek, of, for example, Microsoft Word or Excel. This is a gentleman by the name of Charles Simone. Charles Simone was the lead person on making the Office product at Microsoft. And he went from 4,000 square foot to 22,000 square feet. I put 13 heat pumps, 70 tons in that particular house. You can see there's a terrific amount of glass. Kind of the bottom left down by that artwork, which has that yellow right in the bottom of the house there. That's a large indoor pool. So Charles Simone is also the guy that paid the Russians about 10 years ago, if I recall correctly, 8 years ago or something, to go up to the Space Lab for a week. So that's Charles Simone. I've done a terrific number of Microsoft executives' homes. Houseboats, including the ones all around, the one used in Sleepless in Seattle, as a lot of you have probably seen. Very unique lifestyle, as you can see. People bring their boats and tie them up to their home and step off, and well, they're home. These are completely floating. Some of them are concrete floats. Some of them are old cedar logs. And I've done a lot of these where it's just a natural. I mean, you drill your supply and return pipe holes through the rim joists, and you insulate from freeze protection, obviously, down here up here in the Seattle area, and you suspend your heat exchanger from cables just underneath that houseboat. Again, these don't have motors. They don't move around. They are there. Very, very unique lifestyle, and they work so very well. I've done just a ton of houseboats, so it's really a unique application and a great deal of fun. By the way, since I'm a scuba diver, not that you have to be to put in pond loop heat exchangers, but I will tell you this, after diving underneath many a houseboat, I now know what they do with their Christmas trees after Christmas. And I see an awful lot of deck furniture, hibachis, and potted plants down there as well. Here is a lake plate heat exchanger. This was done up in British Columbia, up in Westminster, up on the Fraser River. I'm very familiar with this area. I go up there fishing at least once a year. You can see that the home had this applied and protected behind that galvanized screening, and it's attached and floated into place and tied up to the dock, similar to what they do in Seattle. I will tell you this, I probably would have put this underneath. I know why they didn't, because they were skidding that house into place, but in my book, this is a little bit tall in the water column. It might start to get affected by ambient temperatures. I think that their saving grace is that this is the Fraser River, so the water is truly flowing year-round. It's not a stagnant condition by any means, but again, I just thought I would show this as just another application technique. Talk a little bit about troubleshooting. Like any geothermal loop, sizing and capacity is critical. Making sure that you are applying your heat loss, heat gain calculations for that structure, and you're matching that up to your heat pump. Next, you need to provide the proper size loop, the heat exchange, to support that heat pump. One begets the other, so you can't skip that step. Improper sizing and or tube spacing, if the heat exchanger is covered, preventing water movement, well, your capacity and performance will suffer, I promise you. Again, if you don't allow for the water movement, if you're using the HDPE coils to circulate around all that heat exchange area, well, you don't have enough heat exchange and you could be in problems, heating and or cooling. You just need to make sure that you're applying it correctly. Plate heat exchangers that work in cooling and suffer in heating, they just don't perform well during the winter. Well, they're typically not sized for the cold water heating application. Again, usually in the northern climate states. Again, you got to make sure that you're applying the correct size of plate or tube style heat exchanger for that water condition, that temperature of water. You want to make sure that whatever you put in is sized for that dominant load, whatever that happens to be for your location. So if you come across a project and you are finding that it's not performing, that's been the complaint. Well, here's something you want to do. You want to consider doing what we call heat of extraction, heat of rejection per the manufacturer with proper instrumentation. Again, one pressure gauge, not two. One digital pocket thermometer through your PT ports. You want to validate that that heat pump is doing its all. You want to make sure you have at least a 15-minute run period so that the temperatures of the loop have stabilized, as well as the ducting if that's involved, and the refrigerant pressures have stabilized. You want to see what's truly going on. If you suspect that the temperature difference going through the pond-style heat exchanger is where the shortcoming is, here's what you want to do. Again, run that heat pump for a bit in whatever the mode happens to be for that time of the year, and then just pull your Y1, Y2 connectors off and allow the pump to continue to operate. And you want to start measuring your temperature difference in and out. If there doesn't seem to be much difference in and out of that pond heat exchanger, again, when the compressor is turned off and you've already tempered that fluid, then you're not exchanging your temperature out there in the heat exchanger. Well, if you're not exchanging temperature, what are the causes? Well, I can tell you from what I've seen, because I've dove down on a lot of old systems. Mud and silt, very, very common. If it was a plate heat exchanger, perhaps it fell over, or in one case I had a customer who didn't like the chain that he saw underneath his dock suspending his GeoPlate heat exchanger. He disconnected it and laid it down against my recommendations. And when he called and told me he was having performance issues, I made sure that I asked him a lot of questions, finally got him to admit that he laid it down. So I told him he got to go get cold in the water and pick it back up and hang it vertically. So typically that's what I've seen on some projects. As I mentioned, I've seen systems where the beaver dam broke and brought in a bunch of mud and silt and entombed the heat exchanger that once was working just fine. In the northern part of the country, pond loops had a bad rap for a while, and it was typically, again, installer-induced issues. It wasn't necessarily an issue with the manufacturer of the heat pump or the system overall. It was typically installation issues. Usually it was caused by inadequate spacing in those coils. You don't have enough heat exchange areas. So what were guys doing? Well, they were doing minimal spacing, if not any. They would typically take those banded coils, manifold them up, add some weight, kick them in the pond. Well, what happens in your your heating dominant climate is you start to drop that temperature, since you don't have all that 300 foot or whatever happened to be a coil as a surface area in contact with the water so the water can flow. You start to build ice. And when you start to build ice, that adds buoyancy. And typically you don't have anywhere near enough weight. And most of these guys put just enough weight to make the pond loops disappear when they install them. So what happens? Well, the pond loop comes back up, and now you, Houston, you have a problem because your pond loop is at the surface. It's typically surrounded by ice, and how are you going to remedy that now? It's difficult to get the ice off of those coils, get them spaced, get enough weight, and get them back down the bottom where they're going to perform. So a lot of the black eyes that pond loops got really, well, they were installer issues. So again, making sure you do it right, you do it properly. Don't cut corners ever, because I can promise you this, in geothermal, if you ever cut a corner, it's going to bite you. I'm going to share with you a couple of stories. My business that I ran for many, many, many years was 100% word of mouth. For 17 years, I didn't spend a penny in advertising. And folks, I mean to tell you, I was backed up year-round with a waiting list. And that's because I had absolutely no tolerance for doing it anything other than correctly. I wanted to make sure that it met my customers' expectations. And by the way, I always followed up afterwards to make sure that it was performing to their expectations, because sometimes you need to kind of readjust that. Perhaps their expectations, they got a little bit misunderstanding. So again, make sure you size, design, and install it correctly. Don't skip any step along that trail, because we want you to be successful, and more importantly, we want you to be profitable. Remember, happy customers tell their friends to use you. Unhappy customers want to dismantle your business, and maybe you too. So make sure you're doing it correctly. So here's a project you can see on your screen. It's in Wisconsin. Again, kind of a balanced load state. You know, maybe slightly more in the heating load, probably. 110 tons. You can see that that's a nice, good-sized pond, good surface area. And guess what? You don't see any indications of what's driving the heating and cooling to this project. And here's the beauty. Significant energy savings, terrific lifespan of the equipment. Folks, I have pond loop heat exchangers and heat pumps out there, 27, 28 years old, still running just fine. You don't have outside equipment, not much in the way of noise. When I did a lot of the Microsoft executives in the area that they live, called Medina, which is the Beverly Hills of Seattle, very, very high income and very high expense real estate, one of the issues is noise, because these guys built their mega mansions within the couple inches of that 5-foot setback from the property line. Well, the City of Medina building inspector always came out to the project site before occupancy, had everything mechanical in that home turned on, and he stood on the property line with a decibel meter. And if you were 1 dB over, Houston, you got a problem. And remember, at that stage of construction, that house is pretty much done. So it became a real issue for a lot of them, because these big houses, they had a lot of load, which meant multiple, typically air-to-air heat pumps and things of that nature sitting outside. Well, I solved that problem. I dropped the heat exchanger in their lake, And I brought my equipment inside. Noise was not an issue at all, and that helped me promote these systems. So that is another thing that I want you to keep in mind. You're not bringing typically equipment outside. So again, when you have a body of water that has the surface area, the depth, you have good access within that distance that we've talked about, you size, design, and install it correctly so that you're utilizing the water flow of that body through the heat exchange surface area that you've applied, it is a terrific source. I had a homeowner that came to my home show booth in 1990 right after we'd had a 3-week-long Yukon Express of very cold temperatures come out of Canada. He came down to my home show booth not because he wanted to see the home show. He came down there just to come up to me and say, Sean, I stood on the ice over the top of my pond loop and my auxiliary heater never came on. Now this is obviously a lot of years ago. At that point in time, we were paying about 4 to 4.5 cents a kilowatt, and he was saving $1,200 a year. And now he had air conditioning. He was ecstatic, and he didn't bring on his auxiliary because I made sure I put in the right size heat exchanger, and I did my load calculations on that particular home. So again, apply it correctly. Do your calculations properly. If you're not sure how to do that, reach out to your distributor or someone that you know that can give you the proper experience and guidance in developing the right application, developing the right heat exchanger, making sure that all your delivery system from your piping to your ductwork, if it happens to be forced air, is done right. Because that's what pays. What costs you is not doing it right, and it's painful. This is a lot of fun, and obviously I'm enthusiastic, and this is something that I very much enjoy. I've done it for a lot of years. Again, 31 years is how long I've been doing this. I've got a lot of systems out there. They're great. They're great. One other thing about pond loops before I take some questions. On pond loops themselves, you typically are going to be pretty decent when it comes to changing equipment. We're starting to see some older geothermal heat pumps starting to reach that age where some of them are being changed. On your ground loop, folks, if you have a 2-speed system, which is probably what you're going to install to replace the older systems, you could actually run into some run fraction issues on your ground loops. Pond loops, you tend not to do that. You probably won't have any issues because, again, as soon as you create that temperature change around that heat exchanger and that body of water, if there wasn't already current present from a spring or what have you, that water's going to begin to move. So you're typically going to be just fine for a little bit more loading coming from the new 410A because you have more run fraction. You also have less waste heat capacity you're taking off the compressor and motors. It's a more efficient refrigerant, so you're going to impact a typical vertical or horizontal ground loop. Pond loops, typically not so much. So that concludes the this portion of the webinar. I hope you found it helpful. I really hope you found some good information here. If there's any questions, I can certainly take those. If we run a little bit short on time and I don't get to all the questions, we can certainly take those offline and make sure to our very best of our ability we can get those answered.
All right, Sean, thanks a lot. That was a great presentation. As that Sean mentioned, we're going to have a few minutes for questions, but he's been kind enough to follow up on any questions that we might not be able to get to in this time. So I'll just start blowing through these, Sean. The first one is from William Moore. Interesting question. Do you have to get approval to put a heat exchanger in a public body of water?
Oftentimes you do. And there can be a number of agencies depending upon where you're at. I can tell you federally there typically is a JARPA. J-A-R-P-A is the acronym. It's a Joint Aquatic, I can't even remember what the rest of it stands for. There's a lot of agencies involved. It takes a little bit of time. I can tell you there's a technique to making sure that you put in there the information that is not alarming to them. I'll give you a good example. One of the things that they always want to know is what is going through the pipe, because they're concerned about more fish and aquatic sea life than anything else, has been my experience. The thing that I found that was very successful for me was this mantra that I would chant. I'm really not kidding when I say a mantra. I would say the following, and I never varied this. I use food grade antifreeze, the same thing that's in ice cream. because that's not alarming to them. Oh, I ate ice cream. I'm not, sick. I'm not dying. The fish probably going to be fine. Okay, so I typically tell them that because I want to make sure that I get my yes on the permit and go through the installation. But I will tell you that after I get my permit and I start to go into the installation mode, I will then start to address, well, look, I want to put in the ethanol alcohol, and I will start to tell them about its same non-toxic features. But I want to get my yes and get my permit first. I still, if they insist and I don't have a choice to put in propylene glycol, it's not the end of the world. I just got to make sure I design my pump and such. But there can be, depending upon your area, some permitting issues. If you run into that, I can probably help you. I won't fill out the form, but I kind of give you some examples of projects that I've used.
All right, great. Next question is from Andy Smart. He's looking, is there a magic height off the bottom of the pond for the loop?
A magic one? Not really. Some considerations how I determine is I try and find out what depth of any mud or silt might be available. Now, I'm a scuba diver. You don't have to be. You can get in a floating rowboat or what have you and take a piece of plastic pipe and go down in the vicinity and take kind of core samples, kind of like when you put that straw in that jar of Pepsi, put your finger over the end and bring it up, you can take a sample. Well, you can do that in multiple areas, determine what is the depth of the mud or silt you're dealing with, so you can design around that. Another one might be if there's milfoil or some of the aquatic growth. I try and keep up out of that bottom where it tends to be the thickest. But no, there's not really a magical number that I look for. If I have a pretty solid bottom, typically if I'm going to use the coils, it'll be those cinder blocks, and those are about 8 inches or so, plus the 2-inch pipe. So that gives the heat exchanger almost a foot up off the bottom.
Okay. This one's from Alan. Are there any issues with beavers that live in the pond or lake? Would they chew through or chew on the PE pipes?
I have never seen that, but I did have one where it was rats. Actually, wharf rats, and it went into the guy's boathouse and chewed through it there. It wasn't underwater. It was where this guy had decided to run his piping up through part of his boathouse, where it transitioned out to the house. And that's only happened, once out of hundreds and hundreds of installations.
Alrighty. Here's another question. Would a closed loop system work in a seasonal pond?
Well, depends on what their load is. For example, if it's seasonal and disappears during the warmer climate, well, they're not going to have any cooling. The system just won't perform. It's been my experience, quite honestly, if it's seasonal, you don't have your pipes submerged and out of sight in a body of water, you don't have the right application. You're not approaching it correctly. It doesn't mean you walk away from that sale. It just means now it might need to be a closed loop in the earth, whether it's vertical or horizontal. But if I have someone tell me that it's a seasonal pond and it disappears through a certain part of the season, I don't do that. Now, I have installed some salt water loops where where I'm at, occasionally on low tide the heat exchanger's exposed. We have that discussion with the homeowner. But remember, if it's exposed, it's just for a matter of hours and the tide comes back in. So you just make sure you have that discussion with the homeowner if it's a saltwater tidal application.
Okay. Liz wants to know, does the heat exchanger affect the water temperature?
It's interesting. Some of the fisheries folks out here in the Northwest, they're concerned about raising, and this is the kind of that makes me chuckle. They're concerned about me raising the lake temperature. Well, Lake Washington, for example, where I've got so many of these installed, is 27 miles long and in some areas 200 feet deep, and I can't even tell you how many, how wide it is. A couple miles probably. They're concerned in Seattle, not known to be a cooling dominant location for sure, that I'm going to raise that lake temperature. Well, I can tell you, when you take a look at the analysis through the software that we have at our website, it's free software, cmdealernet.com is the website, and our GeoDesigner software will allow you to kind of test drive the system. I showed the fisheries folks, hey, up here in the Seattle area, this particular project, and I used my load calculation on this project, I showed them. In the software, it showed that my highest loop temperature during the summer up here was going to hit 71 or 72 degrees, highest loop temperature. And it showed that I had 182 hours of total cooling versus 2,700 in heating. And I just looked at those officials and I said, if you really are concerned about the temperature change and concerned about that increase of pond loop temperature harming the endangered species, which is salmon out here, I said, you want these systems installed, because if you truly think that I can affect it in cooling, by golly, look at what I'm going to take out in heating. Let's do the net benefit analysis. Bottom line is this: it would be extraordinarily difficult to measure that temperature change in that body of water unless you applied it in too small of a body of water.
Okay, great. Question here from Andy. Do you prefer slinky or spaced coil?
You know, I did a lot of slinkies. Early on I did the spaced coils, but I had to make my own spacing. To be honest with you, I'd probably lean a little bit towards the slinky mats as I described. I wish I had some pictures to show. But I have absolutely no qualms with the spaced coils because they arrive ready to go, spaced, and you just need to do the manifolding and put them on that framework. Gosh, it's a toss-up. I would be delighted to use either one equally.
All right. We got one from Darren here. Will a deeper depth position produce a noticeable increase in performance?
When you get below about 8 feet, there doesn't tend to be much difference, again, depending upon your location. You know, if you have that location like in Texas, where they have a terrific cooling load and, you know, very long days of high temperatures, well, that pond loop is going to not only start to rise in temperature, but also obviously the earth around it for, you know, a few feet. In those applications, a little bit deeper, you're going to get better thermal performance. But again, you know, cold drops, heat rises, so whatever you can get for the depth within that 300 feet, that was always my rule of thumb. If I can get deeper, if there's no dock around, you know, if I can get deeper, I'm gonna take it there. Less chance for anybody to get to it, and steady temperatures. Again, in the heating dominant areas, you know, if you had an ice cap on that body of water and you were 8 feet down, the coldest temperature it would get is about 39 degrees. And that heat pump will gladly run there all winter long, happily at good performance.
All right, Sean, we have time for just one more question. This one's from Chuck. How do you design for muddy bottoms? Is not the ground temperature higher than 39 degrees?
Well, the issue with muddy bottom, the muddy bottom is that the heat exchanger will actually disappear into the mud. You don't have enough piping. It's like a ground loop then. Rule of thumb, as I showed on that slide, roughly 300 lineal feet per ton, sometimes 400, somewhere in that neighborhood, for pond loops. Well, that same ground loop length would probably be double that, maybe more. And if you drop into the muddy bottom, you don't have enough heat exchange, you're going to have a terrific struggle trying to meet capacity for that structure. So again, what I would do, and what I have done, is I've designed either PVC table legs, basically a rack, kind of what you saw in the picture with long legs, and make sure that I leave the T's of the PVC tables open to get the air out, and use something like that to keep the pipes up and out of the mud. Now, I did get involved in a heat exchanger where I was going to be in the mud, period, no matter what, and what I did was I made 500-foot slinking mats and I fanned them out, so I designed for a saturated ground loop environment, knowing that this silty environment was likely going to return. And I didn't stack them up either. Again, I fanned them out. So I'm designed for a saturated ground loop, and that project worked quite well. That was 20 tons, in fact.
Okay, sounds great. That's all we have time for. Please join me in thanking Sean Hogan for his presentation, as well, of course, as our sponsor, Climate Master.